Okay, so sine and cosine. How do you get right triangles for angles and circles? So we want in standard position. We can draw a right triangle. We have to be careful about quadrants. And if t is the angle and the point on the unit circle is x, y, the x coordinate is called the cosine, the y coordinate is called the sine. So t equals pi over 4 is an angle. We know that this is now 45 degrees. So pi over 4 equals 45 degrees. So we'll draw my unit circle. Put the x and y axes in the middle of my unit circle. And 45 degrees, or pi over 4, is here. And a unit circle means it's got a radius 1. And so I can build a triangle like this. But this now triangle is my 45, 45, 90 triangle, right? So I know that this length is square root of 2 over 2. And this side length here is square root of 2 over 2. What does that mean about this point? Its x-coordinate is this, how far you went out on the x-axis, and its y-coordinate is this, how far you went up. So cosine of pi over 4 is your x-coordinate. That's square root of 2 over 2. Sine of pi over 4 is your y-coordinate. That's also square root of 2 over 2 because it's a 45, 45, 90 triangle and the two sides are the same length. Okay. What about 5 pi over 4? What angle is that? What's the triangle? What's its cosine and sine? So we'll draw a unit circle. X-axis, y-axis. How do we draw angles where the denominator is 4? Well, that means we want 1, 2, 3, 4 on the bottom, and then 1, 2, 3, 4 on the top. 5 pi over 4, 1, 2, 3, 4, 5. So this angle is 5 pi over 4. Great, and so the triangle we can build here is this one. What angle do we have here? Well, this is each one of these angles is a pi over 4, right? This is 1 pi over 4. The angle between here and here is another pi over 4. That's another pi over 4. So this angle up in the corner is pi over 4. This is also pi over 4. The unit circle, so the hypotenuse is 1. So what does it tell me about the lengths of the sides? Well, this has to have length square root of 2 over 2. This has to have length square root of 2 over 2. But if I start thinking about them as the coordinates of this point, we're going square root of 2 over 2 to the left, right? Which means our coordinate is minus square root of 2 over 2. And then we're going square root of 2 over 2 down. So that's also minus square root of 2 over 2. So that's what this point is. So what's the cosine of pi over 4? Cosine of pi over 5. This is supposed to be 5 pi over 4 here. Must have cut and pasted from the previous one and forgotten to change that. That equals minus square root of 2 over 2, because that's my x coordinate. Sine of 5 pi over 4 is minus square root of 2 over 2, because that's my y coordinate. Okay. T equals minus pi over 3. Draw this angle in the unit circle and find cosine of minus pi over 3 and sine pi over minus pi over 3. So here we're going to end up using the 30, 60, 90 triangle. How do we draw that angle? Well, we're going counterclockwise because it's negative. So I want 3 angles in the bottom. 1, 2, and then 3. And we want just 1 minus pi over 3. So this angle is minus pi over 3. And then if we draw in this right triangle, that means this has to be pi over 6. So if we think of this angle as just being pi over 3 in measure, and this is being pi over 6, we've got our pi over 3, pi over 6, pi over 2 triangle. That's 1. The length of the opposite side is square root of 3 over 2. The length of the side opposite the larger angle, pi over 3, is square root of 3 over 2. The length opposite the shorter angle, which is pi over 6, is 1/2. So what are the coordinates of this point? We go right 1/2, and then we go down √3/2, and going down means we need a minus sign. So x coordinate is cosine, and that's 1/2. Y coordinate is sine, and that's minus √3/2, because we're going down there. What about 8π/3? Find that angle in the unit circle. Well, 8π/3 is more than 2π, because 6π/3 is actually 2π. So 8π/3 equals 6π/3 plus 2π/3. So it's 2π plus 2π/3. This 2π, that just takes us all the way around the circle once, so we can ignore that. 2π/3 means we want angles of size π/3. So 1, 2, 3 angles of π/3. And so this is my 2π/3. And all this is supposed to be inside the unit circle, which I forgot to draw. So this is my unit circle. So if this is 2π/3, then this angle here must be, because halfway around the circle is pi, this angle must be π/3. Or that's tiny. This angle is π/3. 2π/3 plus π/3 is 180. So if we draw this circle in, this angle here must be π/6. So opposite the big angle, your side is √3/2. Opposite the short angle, it's 1/2. So what's the coordinates of this point? Minus 1/2 to the left, and then √3/2 up. And the picture doesn't reflect the actual numbers, because this should be bigger than that, so the angle is actually up here somewhere. But that's okay. We're just sketching here. We're not actually trying to be super accurate. So cosine of 8π/3. Well, 8π/3 is once around the circle, and then 2π/3 around the circle. So you end up at this point, and its x coordinate is minus 1/2. Sine of 8π/3 is the y coordinate, and that's √3/2. So what does Pythagoras' theorem have to do with sine and cosine? 5π/4, we're cut and paste errors. We did this above. 5π/4 is down here. Right? 5π/4. We have a nice 45, 45, 90 triangle. And this is the point minus √2/2 minus √2/2. So why is cosine squared of 5π/4 and sine 5 squared of 5π/4 equal to 1? Well, we could plug in the numbers and just square them, but then we can also, and you'd get 1, and you can do that. But the trick here is to remember that this is a circle of radius 1. So x squared plus y squared equals 1. And the x and the y refer to any point that's on the circle, right? If you have a point on the circle, it's x coordinate squared plus its y squared is equal to 1. But x squared is, well, x is cosine squared x. X is cosine, so you get a cosine squared. And y is sine, so you get a sine squared of t, that's your angle, equals 1. Right? So if this is the angle, t, its x coordinate is cosine t, its y coordinate is sine t. Note something about writing powers of trig functions. what we're talking about is the quantity cosine t quantity squared. But for some reason, we put the squared on the cosine like that. So cosine with the 2 there means the quantity cosine of t, quantity squared. It's mathematical tradition to write the power just on top of the cosine. So that gives us this identity. This is an important identity about cosines and sines. Cosine squared plus sine squared equals 1. It's just the equation x squared plus y squared equals 1 applied to the unit circle. Domains and ranges, right? Cosines and sines of functions. What angles have cosines and sines? Well, no matter what angle you choose, you're always going to point on the unit circle, which always has an x coordinate and always has a y coordinate. So the domain is going to be all real numbers, minus infinity to infinity. So what about the range? Well, cosine can never get bigger than 1, right? Because that's the x coordinate, and the x coordinate of the circle never gets bigger than 1, and cosine can never get less than -1. Same thing for sine. It can never get bigger than 1, because that's the top of the circle. It can never get less than -1, because that's the bottom of the circle. So the range of sine and cosine are real numbers from -1 to 1, or in interval notation that. So what angles have cosine equal to 1? We'll draw a unit circle. Cosine t equals 1 means you have to be at this point, because that's the only possible place that you can have the point of the circle where your x coordinate is 1. Right? And so what could t be? T could be 0, but if you go around the circle once this way, that means 2 pi, or it could be 4 pi, because that'd be going around the circle twice, or 6 pi, which would be going around the circle 3 times, ... Or you could go around the circle the other way, and that would be -2 pi, -4 pi, -6 pi, ... So cosine of t equals 1 when t is a multiple of 2 pi or 0. When is cosine of t equal to -1? That's out here. Right? And that means we're looking for points that have points in the circle with x coordinate equals -1. And that angle is pi that way. Or you could go pi and then another 2 pi all the way around. So that would be a 3 pi. Or you go around twice, and that would be a 5 pi, ... Or you could go negative pi, right? -3 pi, -5 pi. And at this point, your y coordinate is 0, and at this point, your y coordinate is 0. So for all these angles, sine of t is 0. So if cosine is plus or minus 1, then sine has to be 0. And we can do the same thing with sine. Here's my unit circle. Sine equal to 1 is at the top. Right? That means we're looking for y equals 1. That's the top of the circle. And we know that this is a right angle. That's pi over 2. And then we also know that if you go pi over 2, you can go another 2 pi around the circle. 2 pi is the same thing as 4 pi over 2. So once around the circle would be 5 pi over 2. Twice around the circle would be 9 pi over 2. 13 pi over 2, going up by 4 pi over 2 each time. Or you could go negative, right? Which means instead of starting here and going up that way, you'd start and go down around the circle this way. And that would be -3 pi over 2. And then you go -3 pi over 2, and then another 2 pi. And so that would be, what, -7 pi over 2? -11 pi over 2. ... The bottom of the circle down here is where y equals -1. So if we want points, angles, with sine of t equals -1, that's 3 pi over 2, and then we get the usual string of other angles by adding 2 pi, dot, dot, dot. Or you could go this way, that would be minus pi over 2, and then minus 5 pi over 2, minus 7 pi over 2, dot, dot. Great. So when sine is equal to 1 or -1, my x-coordinate is 0. So what does it tell me about all these angles? Cosine of t equals 0 for these angles. Okay. Okay. Even, odd, and neither. So the cosine and sine, even, odd, or neither. We saw these for polynomials back in algebra. And the definitions of these was that an even function gives you the same y value for equal and opposite x values. F of minus x equals f of x. So x squared, an even power. If I take equal and opposite x's, 3 and -3, I get the same y. Odd function gives equal and opposite y values for equal and opposite x values. So odd powers like x cubed, if I plug in 3, 3 cubed is 27. But if I plug in -3, I get -27. So equal and opposite x's, 3 and -3, give me equal and opposite y's, 27 minus 27. So what about for sines and cosines? Here's a unit circle. Here's an angle t. Here's a point on the unit circle. And we know the point on the unit circle, its x-coordinate is cosine, and its y-coordinate is sine. So if we look at the same angle negative, right, then this is going to be cosine of minus t. This will be sine of minus t. But it's the same angle here as it is here. So this point is just, if I just reflect this over the x-axis, that'll give me that point. So this is the same x value, and they have equal and opposite y values because these lengths are the same, but this one is up, so it's positive, and this one is down, so it's negative. So they have the same x value. That tells me that cosine t, cosine of minus t, must be equal to cosine t. And that's an even function. Because if I plug in equal and opposite t values, I get the same x value. Sine of minus t, right? Sine of this angle is down here, but that's the same value as sine of t up here, but with a minus sign. So sine of t is odd. And so then that's that conclusion. So if cosine t is 4/5 and sine of t is minus 3/5, is my unit circle. Going to have to be in quadrant 4 because cosine t is 4/5. That means my x-coordinate is 4/5. My y-coordinate is minus 3/5. Oh, badly drawn circle. So it'll be some point down here. Just fudge the fact that it's not well drawn. So this is my angle. Cosine t equals 4/5. So cosine of minus t is the same, 4/5. Sine of t is minus 3/5. So sine of minus t is the opposite. That would be 3/5. So if this is t, well, t is going to have to be negative because it's down this way, which means minus t is minus minus, so this can be positive. So it'll be up here. That's minus t. And, oh man, my drawings are terrible. This point is going to have x-coordinate of 4/5. And it's just this point reflected about the x-axis, so this comes up here, and y-coordinate 3/5. So if you put in a minus sign inside the angle for sine, you switch the sign there. If you put a minus sign inside the angle for cosine, nothing happens.